Hello, and this is going to be Solidworks CSWA practice problem 7.44. And if you want to follow along with the video, make sure to follow the link in the description, which will take you to the official Solidworks practice problem database. So let's get started. First of all, let's make sure we have MMGS for your units. And then we'll start a sketch in the top plane. Let's make sure we have a horizontal center line so we can align all the circles. And let's have a vertical center line to set up the mirror. Draw some circles along the horizontal. Let's mirror this circle to the other side. Okay. The center circle has a diameter of 40. And the outer circles should have, let's see. Well, they should actually have a radius of 10. If they need to have a radius of 10, wait, yes, if they need to have a radius of 10, then their diameter needs to be 20. Then let's draw a corner or a center rectangle, like so. But let's make sure the midpoints of the sides of the rectangle are coincident with these outer circle centers. So it's coincident, like so. Then let's make sure the distance between, actually we need some points here, so I'll insert some points. One right here, one right here. And then the distance between those 2 points we just created is going to be 105. Sorry about that. And the total height of this rectangle right here is going to be 65. And then there's going to be a little slot right here. I'll mirror those to the other side. Let's close it off. And let's mirror that whole thing on the bottom half. Select OK. Let's add a width dimension of this rectangular cut as being 13. And its side should be 7, like so. 7, 10, and, or 13 and 7 should be it. Then we'll use trim entities. Trim away this part. Same with the circles. And the other side as well. And another dimension that we are missing is that the distance between these 2 edges is 51. Or I guess that's already implied. So what dimension are we missing? Oh, I see. Notice how these lines, these edges, are actually not vertically coincident with the center point of the circle. So we need to fix that. So let's make this line and the center point of the circle or arc to be coincident, and that should have you fully defined. That should be it. So select feature, extrude boss base, then we'll blind extrude it upwards. And since the total height of the part's 51, we'll blind extrude it by 51. Or actually, before I do this, let me take a look back at the sketch real quick. So I think we can make our lives a little easier if I actually include some lines here. Actually, I'm just going to create a center rectangle here. To make this edge coincident with this edge, so, or I guess we can add colline here, and it will apply for the other side as well. And then dimension between these two edges should be 51. Yes. This will just make it, it's easier to extrude this part that's confined by the square first, and then extrude everything else. That way you don't need to go back and make some ugly cuts. So that should be it. So go back to feature, and this time we'll extrude this part first. And as seen from the front view, that should be extruded by 25. We'll select the contour, specifically this square part. Select OK. Let's do another boss extrusion with using the same sketch, but this time we'll do the rest, and like we said before, the total height is 51, and we'll select the rest of the contours, so here and here. See how it already looks closer to the original drawing. 51, yes. Select OK. And now we need to create our front cuts. So start a sketch in the front plane, like so. Now, just like before, let's set up our mirror line. Let's add a corner rectangle down here. Let's mirror this to the other side. Well, actually, let's undo that. Instead, let's make a L cut, like so. And we'll close it out. This way we don't need to do two cuts at the same time. Mirror it on the other side. Select OK. I'll leave it here for now. And then there's two corner rectangle cuts right here. So mirror entities. The other side. Like so. Then we'll add a little bit of a line. Actually, first of all, let's define all of these first before we make the center cut. So this width is going to be 6. Distance from the top of this L to the bottom is going to be 22. And the distance from this edge to the bottom should be 6. And the distance from these two edges, or the distance between the L's, should be 60. And the rectangular cut, this edge of the rectangular cut should actually be collinear with this edge of the L. The other side will follow. And then let's see here. I think that, yes, the distance between these two edges right here should be 13. Like so. Oh, actually, this 6 dimension was incorrect. That's not, I misread that. Everything else is appropriate. What's left to define this is that this edge right here, this edge right here should be a width of 10. I believe there we are almost finished. And then from this corner of the rectangle, actually no, the diagonal line should start here. It should go down until it touches here. Let's find a point, and then it will be a horizontal line like so. And then we will mirror this diagonal on the other side. And then we're going to create some triangles like this. I'll mirror those two lines I just created on the other side. And then we'll close this contour. So here you will have 3 different contours. So 1, 2, and 3. Now we need to define them. So the distance between this rectangular edge and the starting point of the diagonal has to be 6. This is where I messed up the dimension. This is 6. And then as far as this, the distance between these two lines is going to be, I believe it's 50. Is it 51? 51. Yes, 51. This will be 51. There you should have your fully defined sketch. Yes, and all that's left is just to extrude cut it. So go to Features, Extrude Cut. Just to make our lives a little simpler, let's start with the through all cuts. So we'll say through all both, and we'll select the respective contours. So we know this L is a through all, this rectangle is a through all, same on the other side. And then as for the center, it's the only one that's actually pure through all is going to be these two contours, excluding the triangular ones. So we'll start there. So these are all through alls. So click OK, throw both. There you go. Now all you're missing is these triangular cuts. So go back to Feature, Extrude Cut, same sketch. And now let's select those two triangles. If I'm not mistaken, we're actually going to have to mirror, we're going to have to cut it on one side, and then we're going to have to mirror those two cuts on the other side. So first of all, it's going to be cut from a surface, so cut from this front surface, but obviously not through, it'll be a blind. How deep is the cut? The cut is going to be, let's see, the cut should be a depth of 7, so we'll say 7, blind 7. That's correct. Blind 7. Blind 7. Yes. Yes. Yes, blind 7. So blind 7, select OK. And it's cut on this side, but obviously it's missing on this side, so we'll select show planes, primary planes. Oh, flipped it. And then let's go to Features, Linear Sketch Pattern, drop down menu, Mirror. We'll select the front plane as a mirror plane, and then the feature to mirror will be whatever cut we just made. So this cut should mirror on the other side. Select OK. Oh. I see. I see. I know what just happened. The reason why it didn't work is because we did this cut as a we cut it from surface, from this surface. So when it mirrors to the other side, it also reads it as cutting from this surface, which is why it just cut like literally all the way through. So we're not going to be able to mirror that. So I guess we'll just have to do it manually, which is fine. So we'll go back to the sketch. Or actually, we'll just do extrude cut in the same sketch, obviously. And then we'll select the triangle contours again. And we'll keep the blind cut extrude 7, but we'll just do it from a different surface, which is the backside instead. Let's reverse the cut direction, since we just changed directions. Select OK. And there you go. Same thing as a mirror. I believe that should be your final part. Let's double check. Yes, it is. Okay. Let's check the answer. Evaluate mass properties. For your final answer, you should have 220,457 cubic millimeters for your volume, which is the correct answer. I actually first tried that. Nice. Alright, well, hope you learned something from this. Hope you learned something from this video, and I will see you in the next one.